Welcome to the Foundation Lectures on NST. My name is Herwig Mannaert, and in this fifth part we go into more detail into the various dimensions or degrees of freedom of variability and evolvability in software systems. We have seen in the previous parts that we need element structures, that we need to transform functional entities into element structures that interconnect with the cross-cutting concern solutions. And we have defined 5 types of elements which are closely aligned to the basic fundamental software concepts underlying all processors and programming environments. We have also stated that it seems obvious to use code generation techniques to create instances of these recurrent element structures, and we call these code generators expanders and the process expansion because we use highly simple structured templates which are quite deterministic in nature. Now, we can represent this transformation where we have on the left-hand side the functional entities, data entities, task or action entities, which are transformed into structured elements, where the central class representing a data entity or a task entity is surrounded by a number of classes interconnecting with tapping into the various solutions for the cross-cutting concerns. And due to this well-separated and encapsulated element structure, if we want a modification, for instance adding an attribute in the requirements domain on the left, we may have multiple impacts in the software modules on the right. However, these impacts will be confined to, encapsulated within these elements, and will not propagate as dynamic instabilities throughout the software structure of the entire system, will therefore not grow with the system and will not become unbounded with the system. Now, we also have stated that it's very important to be able to not only generate or expand these recurrent structures of the elements, but we need also to be able to adapt them over time, to overcome flaws, technological changes, to make improvements. So it is absolutely crucial that we have a mechanism to regenerate or rejuvenate on a regular basis this recurrent structure, while at the same time being able to keep our custom code that is unavoidable, inevitable, and to re-inject the custom code craftings into the regenerated recurring structure. Now, crucial there is that we have a number of dimensions of variability, a number of dimensions along which the software evolves, and that we have to separate them very cleanly. We have the models, we have the skeletons, the recurring structure, the utilities or infrastructure you use for the cross-cutting concerns, and the custom code of craftings. It is absolutely crucial to separate and encapsulate these dimensions very well, because if we do, we get the ultimate benefits of modularity, enjoying having the product of all the various versions and variants at our disposal, while only having to carry the burden of the sum of the various versions and variants of every dimension. That is absolutely crucial, and if we don't separate and encapsulate these dimensions of variability well, we will have to carry the burden of the product of the possible versions and variations. Now, in order to integrate these dimensions of variability and expansion, in order to have a structured overview on these various dimensions of variability or degrees of freedom, we developed the prime radiant. And the prime radiant is called after the famous device in the Foundation series of Isaac Asimov, where it is a device that allows you to see and distinguish structure in an otherwise chaotic and complex universe. So the prime gradient is a tool that should allow you to master the various dimensions of variability, to have a structured overview and to combine them without they becoming entangled. If we look, for instance, on this schematic representation, we have the 4 dimensions of variability. We have at the left the models, the entity relationship diagrams, the data models, the task and flow models. We have the templates, the skeletons, the template skeletons of the recurring structure of the elements. We have the utilities, the frameworks that solve for us, deal with the various cross-cutting concerns, and we have the custom code or craftings. Now, the prime gradient allows you to have a structured overview over these various dimensions and to combine any version or variant of one of the dimensions with versions of variants of the other dimensions. So it allows, enables, and even enforces you to structure these various dimensions, to separate them well, in order to only having to maintain the sum of versions of variants in these various dimensions and to enjoy the product of all combinations of versions and variants. Now, how does such an expansion or code generation goes about? Well, for every functional entity, for instance an invoice data entity, a data element is instantiated. The skeleton templates are instantiated based on the actual parameters of this data entity. They are called invoice, they have, for instance, attributes like number and order, and this instantiated element, consisting of a set of instantiated classes, is put into the code base. We do the same thing, and also these classes within the element are there to interconnect or tap into the various frameworks for the cross-cutting concerns. Now we do the same thing for other data entities, so the entity relationship diagram, for instance an order, the template skeletons are instantiated. These instantiated set of classes are added to the code base, and these classes that are part of the template, of course, serve to interconnect with or tap into the various frameworks dealing with the cross-cutting concerns. The same is valid for other functional entities, for instance for task entities instead of data entities. There we have an instantiation not of the data element templates classes, but of the task element template classes. Nevertheless, according to the same mechanism, we have an instantiated task element, and this instantiated task element is added to the code base. Within this instantiated task element, we have various classes interconnecting with tapping into the cross-cutting concern frameworks, and for instance for the task elements that would be still access control but no persistency, and for instance transaction framework. The same would be valid for the other task entities. For every task entity we would have another instantiation of the task element. This instantiated task element is added to the code base and contains a number of classes interconnecting with the various frameworks of the cross-cutting concern. And we have the same thing for instance, the third task entity, leading to an instantiation of a third task element being added to the code base, and the various classes responsible for interconnecting with the cross-cutting concerns actually interconnect with the appropriate frameworks. Now, when all these elements have been instantiated and connected with the various frameworks dealing with the cross-cutting concerns, we can add, of course, the custom code consisting of injections at one hand, code snippets being injected into the various anchor points of generated or expanded classes, and we have the extensions, the separate classes which are separate classes in the code base and are of course also called from linear insertions. Now, important is that we now have a structured overview of the various dimensions. And the first dimension, or degree of freedom, along which we can have changes and evolution, is of course the models or the mirrors. The models of the data entities, the functional entities, the task entities. So if we would have there a change, for instance, additional attributes to the invoice, then of course we would have changes in the various classes of the invoice element, but not outside that class. Now, to be more specific, information systems based on normalized system theory, generated using normalized system expanders, guarantee stability with respect to a number of changes. While the design theorems are necessary but not necessarily sufficient conditions to have stable software without dynamic instabilities, if you use the element structures, if you use the normalized systems expanders or code generators, we guarantee stability with respect to a number of changes. So a first category of changes is located in the dimension of the models or mirrors. So the first thing that a normalized system, software system, guarantees is that you can have a new version of a data entity, including additional data attribute, in a stable way. So adding data attributes, having a new version of a data entity, will not lead to dynamic instabilities. Consider, for instance, the invoice as a data entity. It will be instantiated in a data element containing a number of classes. That data element contains a number of data classes, action classes. And if we add an attribute, well, it could be possible that there are changes in multiple classes. However, they will be limited, as we have stated, to that element. So we can see that the set of marginal classes is bounded and is not growing with the size of the system, because it is bounded to the set of classes belonging to that data element. And so the marginal set of new versions of software modules or classes is bounded by the number of classes of that element. Now, a couple of remarks. Not all of the classes will be impacted, for instance. Suppose that it's about data attributes, for instance, the details class representing the core data of the invoice will be impacted, the invoice data class dealing with the persistency will be impacted, but for instance, the remote agent and proxy classes will not be impacted. So indeed, it will be a subset of the classes of the data element corresponding to the invoice. Concerning the crafting code, well, of course, we guarantee that the crafting code, the custom code, will not be impacted as long as it only uses the provided technology agnostic interfaces. It only uses the interfaces we publish and we encourage to use. If inserted custom codes would cut directly into certain internal methods, which it is not supposed to do, it could be that the custom code needs to be adapted a little bit. But that would still be stable and would be outside the scope of normalized systems. Another change you can perform, which we guarantee to be stable without dynamic instabilities in a normalized system, is that you can implement an additional data entity in a stable way. Now, suppose you say, look, I need a new data entity in the model. Suppose there wasn't yet an invoice. Then, of course, that new data entity would be instantiated, expanded into a data element that consists of a number of classes, and of course the number of marginal software modules or software primitives is limited to the number of classes of a element. So part of, in this case, the marginal set of software primitives is the entire new data element. So it's not a part of it, but it's an entire new data element, as many classes as the data element contains, and that is it. Considering some other stable changes we guarantee that you can do are located at task level. You can have an additional task implementation in a stable way. Suppose you have a task entity, you want a new implementation, yes, add another implementation. The only thing you really need is an additional implementation delegate class and basically nothing more. So you actually only can do this with a single additional class. So the marginal set of new versions of classes or software constructs consist of an additional implementation delegate, and you can select this delegate by simple configuration of any normalized software system. You can also perform the requirement change to have a new mandatory task implementation in a stable way. Once again, suppose you have a task entity, that task entity is transformed into implemented in a task element. Well, in case you have a new and mandatory implementation, for instance, a new and mandatory protocol to collect data from an IoT sensor, you just have to implement an additional implementation delegate. And so the marginal set of versions of software constructs consist of an additional implementation delegate. And you can make it mandatory by simple overriding the previous class version or by simple configuration. Another change you can do in a normalized software system in a stable way is you can have an additional processing action implemented in a stable way. If you want just to add an additional processing action, suppose the send invoice would not have existed yet, the only thing you have to implement is actual implementation of the task element consisting of all the various classes of that task element. So the marginal set of new versions of software primitives or classes is the set of classes belonging to being part of that single element. Now we can remark that the marginal set consists of the entire new task element, and that is about it. Another stable change is related to the flow element. So you can have new state transitions in the state machines of the flow. They can be added or modified in the sequencing flow of the flow element state machine in a stable way. Suppose you have a flow element which is implemented in an instantiated flow element, flow entity implemented in a flow element, consisting of a number of data and action classes. And if you would, in the requirements domain on the left, ask for additional or other state transitions, the only thing you would have to do is to configure either the state tasks at the runtime of the normalized software system or the data flow task at design time of the design of the normalized software system. You wouldn't even have to implement any new classes or versions of classes, so the marginal set of classes would be empty. Another change at the level of the flow is you can have an additional sequencing flow implemented in a stable way. If the requirement would be to add an additional sequencing flow entity, you would simply have to implement or instantiate the various classes of the flow element for this new flow entity, and so the marginal set would consist of the entire set of classes of this flow element. Now, the entire new flow element would be the marginal set of versions of software primitives, and that's about it. A second dimension of change corresponds to the utilities, the frameworks that you are dealing with to solve the cross-cutting concerns. Now, suppose that you would say, look, I want to use another transaction framework, for instance, another framework for specific cross-cutting concerns. The only thing you have to do is to change the various classes interconnecting with tapping into that framework. And those various classes are located within the element structures, and there are only a limited amount of classes dealing directly with that framework. You could even just, if you have an expansion environment, change the template class which deals with that framework. So the stable changes we guarantee there is that if you have a technology implementation of a specific concern for one element or a listed set of elements, you can change this in a stable way. Suppose you have a number of elements and they interconnect through one of the element classes with a framework dealing with a cross-cutting concern. Then the only thing you would have to change in the code base, if you would want to change this utility framework for a number of elements, you would have to make new versions of those classes in those elements interconnecting with that cross-cutting concern framework. So the marginal set of new versions of software classes would be limited to those classes that are part of the elements dealing with that cross-cutting concern framework in that set of elements. So this change would even be bounded even if you had no expansion or code generation mechanism, because it's only for every artifact where the technology corresponds to that utility that you would have made the change for every listed element. And this is a bounded set, even if you have no expansion or code generation mechanism. Of course, once again, you would suppose that the custom code or craftings do not make direct calls to the utility frameworks. Otherwise, that would imply change as well. However, we ask and impose that those craftings do not make direct calls into the utility or cross-cutting concern frameworks. Now, if you have a code generation or expansion mechanism, which you as normally in normalized systems development, then we can even guarantee that you can have an additional technology implementation for a specific concern and make it available in a stable way for every element of every information system which is generated using the normalized systems expanders. Because if you use the expansion or code generation mechanism, you can have an unbounded set of elements in even an unbounded set of applications or information systems, and you can simply change every class of every element in every information system by changing the template class, interconnecting or tapping into that utility framework, and by rejuvenating all these information systems. And so you could even change the implementation of a certain cross-cutting concerns in an unbounded set of elements, in an unbounded set of applications, by having a bounded change consisting of those templates within the elements, those templates within the element templates that interconnect directly with that cross-cutting concern framework. So part of the marginal set is all the elements for which the technology corresponds to that utility. And you can even do it through configuration and define a setting or an option. Of course, once again, we suppose that the custom code craftings do not directly call into the utility frameworks. In case they would do that, which they shouldn't, then you could have additional changes required in the custom code. Now, another thing which you can guarantee if you have normalized systems expansion and code generation framework is you can have a new technology implementation for specific concern and make it mandatory for all information. So suppose you want to change in a mandatory way the transaction framework, the framework solution dealing with the transaction cross-cutting concern across all elements of all normalized information systems. Once again, you would just define the new utility transaction. You would adapt, modify, make new versions of the corresponding classes interconnecting to that framework or cross-cutting concern solution, and by regenerating all applications, all elements, all recurrent structures, you would automatically get all applications updating and interconnecting to the new cross-cutting concern solution. Once again, the marginal set of additional versions of software classes consists of the templates of the various elements, the templates for which the technology corresponds to that utility. So it is bounded by the set of template classes in the elements. It is smaller and bounded by the set of template classes. And you can make it mandatory by configuring it and overriding all previous template versions. Once again, this assumes that you have not made any direct calls into that utility framework through the craftings, which you are not supposed to do. So you also, of course, have the dimension of the skeletons themselves, and the skeletons themselves, they can provide you to deal with other utility frameworks. They can provide you and support you to deal in a stable way with new implementation of utility frameworks dealing with cross-cutting concerns. However, they can also be changed for other reasons, be changed because you improve or correct flaws in the recurring structure. You improve the skeleton templates. Or you can also say, for instance, look, it is possible to add an additional concern which was not present yet, an additional cross-cutting concern. For instance, an additional security requirement, privacy requirement, or whatever is demanded by the government to be obeyed in information systems. So you also can add additional concerns to an element in a stable way. Now, suppose that you have a number of elements and you say there is a new concern. Well, the new concern may require that you introduce additional clauses into the element structure. But if you have the expansion code generation environment, you can regenerate, rejuvenate all elements of all normalized information systems, and therefore extend all these elements with the new additional classes you may need to take care of this additional cross-cutting concern. And so the marginal set of classes for which you would have to make new versions would be bounded by the total set of existing and new template classes of that type of element, because it may of course impact not just the introduction of a new class in the element template skeleton, but also to modify some existing template classes. So the marginal set would be all those template classes for which the concern is equal to the concern you want to add, and you could do this by setting an option. What you also can do in these skeletons is adding an additional concern and making it mandatory for all elements of all information systems which are generated and rejuvenated using normalized systems technology. So you could say, I have a number of elements, I have a new concern. For this new concern, I might need to add additional template classes to the element structure. But if you have done that, you can regenerate all normalized information systems, and all the elements will be extended, and the new class dealing with the new concern will be introduced in all the elements, and maybe other modifications in the existing template classes as well. So the marginal set of new versions of software primitives would be upper bounded by the set of software templates for the specific type of element as a whole, because you could not only have a new class but also maybe changes in the existing template classes. All template classes for which this is the concern, and you can make it mandatory by just demanding that that template is always applicable or true. The last change dimension in the craftings, of course, we have been saying already that you have to take care. The craftings should be tested in a CI/CD environment. They do not make direct calls to the technology frameworks, that they do not make direct calls to illegitimate interfaces. But the craftings, it's also important, they can be changed and they can be re-injected into the structure of the software. So both the injections which are located within anchors in the generated or expanded classes and the separate extension classes can be changed over time. It is important to group those craftings, both injections and extensions, in certain features, because the reason you make custom code, you introduce custom code, is to implement certain features required by the user, required by the business users, and of course it is important to keep track of the traceability between the features required by the user and the various insertions and extensions that implement these features. So, if you have any remarks or any questions, please contact me. Thank you.